Now that you've explored some of the ideas behind where exponents and exponential growth come from, we're going to look at how to work with terms that have exponential expressions in them with numbers. So I think that what we've figured out now is that at each level in a tree that's growing exponentially, you're going to have powers of 2. So here you have 2 to the 1, here you have 2 squared, here you have 2 to the third. 1, 2, 3, 4, 5, 6, 7, 8. Right? So in any tree like this, where something is growing exponentially, and the pattern that's occurring is every time you're multiplying by 2. So what if you had something like this, where you wanted to multiply 2 to the 5th times 2 to the 4th? Sorry, 2 squared. That really is saying you have 2 5 times 2 2 times. So how many 2's are there? 1, 2, 3, 4, 5, 6, 7. So that is 2 to the 7th. So what did you really do? Where did the 7 come from? It came from the 5 2's here and the 2 2's here. So basically you're adding the exponents because you're counting how many of that base you have, right? That's why you're adding the exponents, because this number that is the exponent is telling you how many 2's you have. So what if you had something like this, 2 to the 5th plus 2 squared? Can you just add the exponents there, right? Can you just do 2 to the 7th? So what does that really mean? That would be 2 times 2 times 2 times 2 times 2 plus 2 times 2. So when you're adding them together, you're not really doing the same operation like you are up here, right? This is all multiplication and this is all multiplication. But then when you're adding, it's not the same. So you can't just count how many there are, right? Multiplication is the same in this whole expression. 2 times 2 times 2 times 2 times 2, right? They're all times. But this one has a plus in the middle. So when you're adding, you cannot add exponents. And that's a really important thing to remember. Okay, I know it seems kind of counterintuitive, like why you can't do that, but it's really important to note that. Another important question to ask yourself is, why do we have to have the same base all the time? And you got to think about that when we talk about division, okay? So if I'm doing 5 to the 8th divided by 5 to the 3rd, which is the same as 5 to the 8th over 5 to the 3rd, right? That means division in both cases. You're counting 8 5's and 3 5's. And as you know, when you have common factors in the numerator and denominator, they can cancel out, right? You divide by 5 in the numerator and 5 in the denominator. 5 in the numerator and 5 in the denominator. 5 in the numerator and 5 in the denominator. So what do we have left is 5 5's in the numerator. So we have 5 to the 5th. So what did we really do? We actually subtracted the exponents, because what's left over is the difference when you cancel the 5's that are there with the 5's in the numerator. So it's 5 to the 8 minus 3, which is 5 to the 3rd. And the same thing goes here. There's a reason why you can't do, if it was 5 to the 8th minus 5 to the 3rd, notice that if you had 8 5's minus 3 5's, there's no canceling that would happen. So you wouldn't be subtracting the exponents. So that's a no-no if you're doing subtraction. So it's only for division that you can do this. So let's talk about why you have to have the same base. Can you see why now? Because if they're not the same base, this canceling wouldn't happen, right? If this was 5 to the 8th divided by 2 to the 3rd, the 2's would not cancel in the denominator and the numerator. So that's a really important thing. So another operation you're going to have to do is raising a exponent to another power. So for example, if we have 7 to the third squared, what does that mean? When you square something, it means you multiply it by itself once, right? That's when you square it. If it's to the third, you do it 3 times. So that means now we can just use the rule of multiplication. So you would do 7 to the 3 plus 3, which would be 7 to the 6th. So a shortcut there would actually just be to take these two exponents and multiply them together. So it could be 7 to the 3 times 2, which also is 7 to the 6th. So another example would be if you had 5 to the third raised to the 4th, that would be 5 to the third 4 times. And it would be 3 plus 3 plus 3 plus 3, which is 5 to the 12th. So basically all you're doing is 5 to the 3 times 4. So the new exponent is the product of the two. Okay? All right, so here's a really simple example that you can't combine any of these because, first of all, they don't have the same base, and second of all, you're not multiplying or dividing. All you're doing is subtracting and adding. So this is a case where none of the rules that we just talked about applied, but hopefully this is something that you can do. So 2 to the 5th is 32, minus 6 squared, which is 36, plus 3 cubed, which is 27. So 32 minus 36 is negative 4, plus 27 is 23. So that's just a straightforward way of using exponents with numbers in the first place. All right, so what would you do with something like this? You have multiplication and division mixed together. Well, if you think about the order of operations that you've learned before, you do parentheses, and then you do exponents, right? So you are allowed to split this into the things that have the same bases. This is the same as 6 to the 4th divided by 6 to the 3rd times 3 squared over 3. That is totally fine. So 6 to the 4th divided by 6 to the 3rd is 6 to the 1, right? You subtract, times 3 squared over 3. That's really to the 1, right? So this is 3 to the 1. So the answer is 18. So in this problem, you actually have a combination of a bunch of operations that you need to do. You can do them in lots of different orders, but let's stick to the order of operations and do what's in the parentheses first, right? And then the exponents. We can't combine the 7 and the 4 or the 7 and the 4 because they don't have the same base. So let's do the exponent. So the numerator becomes 7 to the 12th times 4 to the 8th because we're multiplying, right? You're raising it to a power. In the denominator, we're getting 7 to the 10th times 4 to the 15th. Now we can divide, right? You subtract exponents when you're dividing. So it's going to be 7 squared. And if I subtract here, I actually get a negative answer, 4 to the negative 7. And that's going to be our next video. And maybe if you already know what that is, that's great. And if not, we'll definitely cover it. Okay? Thanks so much.